Welcome to qnawire.
Problem 34.5, where we have a concave mirror. Right. This concave mirror has a curvature radius of 22 centimeters, and therefore it has a focal length of 11 centimeters. And there is a object that is 16.5 centimeters away. So that's S. All right. So S is 16.5. The height of that object, the size of that object, is 0.600 centimeters. The first part of the question asks to draw a one. So R, the curvature radius is 22. So again, the first part of the problem asks to draw the principal ray diagram. So the first principal ray is parallel to the axis. So it goes from the object parallel to the axis, hits the mirror, and then reflects and passes through the focal point. All right, and then the next one is a ray through the focal point and is reflected parallel to the axis. Sorry. All right, ray 3, a ray along the radius, through or away from the center of curvature, and is reflected back along the original path. And then the fourth one, a ray to the vertex, and then makes a equal angle. So I'll do that one first because that one's a little easier. So ray to the vertex, and then that makes an equal angle. And then back to 3, ray along the radius. All right, so it's along the radius. And then because it's along the radius, it will make a right angle here. I should do it. Actually, that's the wrong direction here. I'll erase this. It's not the way to think about it. So along the radius, intersects, and then back along its path to here. So now the second part of the question asks to determine the position. So we know that 1 over S, so S is the distance from the mirror to our object, plus 1 over S prime is equal to 2 over R. All right, so we can, what we're trying now to find is S prime. So S prime is the distance from the mirror to our image. So if we manipulate this equation, we get S prime equals 1 over the quantity 2 over R minus 1 over S. All right, and I did that first by bringing the 1 over S prime over and subtracting it. Or sorry, 1 over S, sorry. Bringing the 1 over S over and subtracting it. So once you bring this over and subtract it, And then inverting because we have a 1 over s prime. So then it becomes s prime equals 1 over the quantity 2 over r minus 1 over s. Now we can plug our numbers in. So we have s prime equals 1 over the quantity 2 over r, where r is 22.0 centimeters, minus 1 over s, where s is 16.5 centimeters. All right. All right, and then we calculate that out, and we get that s prime is 33.0 centimeters to the left. All right, now we can look at the next part of the question that asks for the size. So we're going to be looking for this, how tall it is. So y prime, and we know that we can relate y prime and y. So we know that y prime, or not. So we know, okay, we know we can relate y prime to y via m, which is the magnitude of magnification, where that is also equal to minus s prime over s. Now if we plug our numbers in, s prime is 33.0, and we'll divide that by s, which is 16.5. Now if we divide this out, we get a minus 2.0. Now this negative sign here tells us that our object will be inverted compared to our image. So our image will be inverted compared to our object. So that gives us the orientation, and that it's twice as big. So we know that y prime will equal m times y, where m is 2.0, so it's minus 2.0. And our original y, so the original size, is 0.600. Now we multiply this out, and then we can get that our figure is the size of 1.2. Now this is in centimeters. Now we still have the negative sign because the negative sign refers to the object being inverted compared to our original y, to our original object. The next thing it asks is the nature. So is this object real? So is our object that is formed over here real or inverted? Okay, so this object is real, and it is real because that S, the object, the distance from the object to the mirror is larger than the focal length, and that will make our image real. Now, if S is smaller than if the image was over here smaller than the focal length, then that image would be imaginary. All right, thank you.